Thank you very much, Ryan. That was a very kind introduction. I'd like to thank you for organizing. In fact, I'd like to thank the whole Vic Myers team for organizing this event. And I hope the audience finds it helpful. So let's get started. We're going to be talking about GPS resiliency and talking about a solution that we refer to as a GNSS firewall. So this is what the agenda looks like. First, which I think will be helpful, is we're going to provide some background on what's been going on in the industry, specifically in the position, navigation, and time, the industries that use PNT. Then we'll give you a brief overview of the BlueSky GNSS Firewall and kind of a quick summary of how it gets deployed into a PNT environment. Then we'll dig in a little deeper to a topic that is very important when you're trying to build a resilient PNT environment, and that's the ability to monitor and measure what we call GNSS observables. And we have different ways of doing that, of charting and performance monitoring. Then we'll have some summary and leave plenty of time for questions. So to get started, when I first actually got involved in this particular area about 3 or 4 years ago, and was probably like many of you reading lots of the news articles on this subject, I decided to make a trip to Norway. And people kind of scratch their head a little bit. Why are you going to Norway, right? Why Norway of all places? And Norway, and in fact the Norwegian Sea it is the key battlefield, if you will, for jamming and spoofing. It is even today, I think you could probably find more articles of jamming and spoofing around the area of Norway and Sweden and Finland, even Denmark, and down there to the UK, because primarily due to the activity from Russia, most notably in the area of Russian battleships kind of making that turn around the corner there and going along the coast of Norway and being able to generate some incredibly powerful jamming and spoofing interruptions. They do a lot of their battlefield maneuvering and create a lot of problems. And there has just been repeatedly problems reported from Norway and other neighboring countries about the problems that they see in their country's critical infrastructure, whether it's a utility company, a telecom company, a railway, of course, data centers now and financial institutions. All of these critical infrastructures use GPS, or now more broadly referred to as GNSS, to capture all of the different constellations. And they were having, and still do today, have tremendous problems with jamming and spoofing because of that activity. And the problems are serious. They're not just serious from the perspective of interrupting business operations, of being disruptive to really important homeland security, but we're talking, and I say this with all sincerity, we're talking about people's lives potentially being affected here, and especially as you get into the area of aviation, where GNSS is used more and more and more instead of traditional instrument landing systems. It's something that can affect human life. So it's no joke, and this is another quote actually out of Finland along those lines. So a lot of industry activity, a lot of news. It's real news, and it's ongoing and growing and growing. In the United States, switching back over to the United States, what's been going on here? Well, there's been a lot of talk no question about that. There's been a lot of discussion about the topic. And there's even been a little bit of movement in government in previous years. But now, all of a sudden, this has taken on a much, much higher level of importance and a much higher level of urgency. And in fact, what's occurred, if you haven't heard about it, is there was actually an executive order that was issued. And I've got in the slide deck, which you'll get a copy of, the URL, where you can read that executive order directly from the White House, which talks about, basically be more responsible with the use of position, navigation, and timing. And this is an executive order directed straight at the critical infrastructure operators here in the United States, as I mentioned before, right? Everything from, data centers, which you could consider a new kind of critical infrastructure, to our utility grid and our telecom networks, traditional critical infrastructure. A lot of the underlying work that the government, the organization of the government turns to for driving a lot of this activity around this executive order is driven by the Department of Homeland Security. So I gave you a link there too, to the Department of Homeland Security, their website specifically. And then also, there's a pretty interesting article. I read a lot of GPS World and Inside GNSS. This particular article, which you'll have the link to, deep dives into this executive order and, has some pretty good, I think, interviews with a lot of the government officials who are involved in this executive order, and really how they voice the importance of the country taking action, to do something about this problem of spoofing and jamming of the GPS signal. And of course, what we're going to talk about today is a solution that we have. We'll give you a brief overview. Obviously, there's a lot to it. We'll only go so deep on it, but we'll certainly introduce you to the BlueSky GNSS Firewall, which is designed to solve this executive order. What's interesting as you read some of these articles that I just mentioned, and you'll, of course, I think we all know about the Department of Homeland Security, but what's occurred now is there's a new organization called the Cybersecurity and Infrastructure Security Agency, CISA, and they're really the key pilot here in driving action around this area, because this problem of spoofing and jamming the GNSS or GPS signal, it's viewed as a cybersecurity problem. Okay, and so it's used by all of the critical functions, as we've already kind of described. Position and navigation and timing is a key part of our national critical infrastructure. And the key takeaway from this slide is that it's viewed as a cybersecurity problem. So the approach needing to be taken to solve this problem is really one that's very similar to how other, for example, network security problems are solved. And we'll talk about that in more detail. And here's a little bit more along those lines of why they view it that way, because these threats of jamming and spoofing have become increasingly simpler to do. Okay, so you can literally take a computer board, a Raspberry Pi board, or something like that, and very easily create a software-defined radio that can cause a lot of problems. The software, the spoofing and jamming algorithms are out there. If you search for them on the web, the hardware is easily accessible. And so, the ability to create these weapons at some level, they could be called, is quite easy to do. And that's why DHS is so concerned. And now, even at the highest level, our president is concerned about it. And there's a lot already happening by DHS and the CISA organization, and you're going to hear a lot more about it. There's most notably a conformance standard being built. I've personally been involved in it, as have a couple of others from the Microchip team. And it's an industry effort. It's a government, industry cooperation. It's been quite effective in my experience in developing standards. They've moved very quickly, and this is a snapshot of kind of what that framework looks like. They refer to it as a framework. And what's interesting about this document is it's, a lot of us, when we think about GNSS, when we think about position, navigation, and time, we think about parameters of accuracy and precision, for example. But this document is not about that. This document is about security. It's about resiliency. It's about recoverability. It's about being able to maintain and operate a PNT infrastructure under any kind of condition, whether it's one little location jamming, spoofing event, or a much larger, wider, broader outage that maybe even lasts for multiple days or even weeks. So it's a framework to capture, again, that security, resiliency, recoverability, capability that is needed, and that's what they refer to as responsible PNT. And so this document is actually, the first draft is just become available. It will be finalized before the end of the summer. They're moving, like I said, very quickly on it. We're very involved with it, and it's going to become very relevant to our Homeland security going forward. So that's some backdrop for you on kind of what's going on in the industry. I went through that pretty quick. There's even a lot going on globally. This is not just a problem in the United States, as I already showed in Norway, but issues are being seen around the globe. I'm certain you could imagine the type of issues that pop up in the Gulf region. But really, these kind of incidences are amazingly popping up in all parts of the world: Asia, Europe, Latin America, United States, and everyone's starting to really pay notice. So this next section, we'll jump into the firewall product a little bit. But before doing that, I wanted to, I like showing this slide because it's been surprising to me how many times I've talked to customers and I've made the mistake of assuming that they know the difference between civilian GPS receivers and military GPS receivers. And I'm sure this audience, as I would imagine, being based here mostly probably in the United States and maybe even quite a few military agency folks on the line, this is common sense or stuff you would easily know. But if you don't mind, I'll take a minute. When GPS first came out, it was always known from the beginning. I mean, it's been out for over 40 years now, right? It's by far the most proven of the constellations. It was always known that GPS, though, was a fairly insecure signal, that it was a fairly fragile signal. And so the military, from day one, always had a specialized receiver that they used for receiving the GPS signal, and they call that a SASM receiver. You'll see the acronym right there. And that stands for Selective Availability Anti-Spoofing Module. So the military has always had a plan, has always had a solution for the potential threat of jamming and spoofing. And in fact, today, what you'll read more about and see products from our company with this capability is a new generation of a military receiver that's referred to as M-code, which is in simple terms, kind of the next generation SASM receiver. And we'll be coming out with products actually with an M-code receiver in it. But most of the world, and most importantly, the critical infrastructure in our own country is all using civilian receivers. They're not using any military receivers, only civilian receivers. And these civilian receivers, you know, in the beginning were really thought to be used maybe for car navigation systems and kind of individual consumer related applications. They weren't expected to be used in a utility grid or in a telecom network or, you know, in a railway system. It was never anticipated how broadly civilian GPS receivers would be used in our homeland critical infrastructure. And that's what caught everyone off guard, especially as these incidents started popping up. And that's what got the attention of the government. And that's what caused us to create BlueSky, and specifically the BlueSky GNSS Firewall, is to protect the receivers that use, the systems that use these civilian receivers. And the approach we've taken is very similar to a firewall. Just for fun, I showed a physical firewall, right, that we're all familiar with. Of course, probably most notably that we're all familiar with is the idea of a network firewall, right, where you've got internal assets inside of your enterprise, and you want those assets to be able to communicate in and out over the internet with other locations. And so you put in a security firewall to do that, to constantly analyze and evaluate the traffic that's going in and out of the network, and in and out of your enterprise. Well, what we've done is applied that same concept of a firewall, but instead of protecting what's going in and out of the enterprise over the internet, we're protecting what's going in and out of the enterprise from threats from the sky, if you will, right? So we've taken the same concept of a firewall and applied it to protecting against jamming and spoofing, or what's called complex jamming, lots of different terms used there. Basically, any kind of sky-based threat that can come from what appears to be a GNSS signal, but maybe is not. We've applied this concept of a firewall to protect and make sure the PNT information that's being used by the downstream infrastructure is good, is not being violated, is not fraudulent, is not insecure, just in a general sense. And so here's a picture of the firewall itself, the BlueSky GNSS Firewall. You can see my mouse going over it. And it sits very simply in between any standard GNSS antenna and the downstream infrastructure. Or you can think of this infrastructure more specifically as, let's say this was the GPS receiver, or maybe even multiple systems using GPS. The firewall sits right in between the antenna and that downstream infrastructure for the purpose of protecting at a highest level against spoofing and jamming. It's a very simple connection. It doesn't require a new antenna to be installed on the roof. You just disconnect the antenna from your existing receiver and insert the firewall in between. Connect the antenna to the firewall, and then there's an output from the firewall that goes to the downstream receiver, and I'll show you more details on that in a minute. We've got some interesting options that go into the firewall. It can be deployed with what we call our miniature atomic clock, or MAC. It's a rubidium oscillator that provides this holdover capability, and I'll explain that in more detail. We've got some other interesting ways to hook up external atomic clocks. For those of you who have a cesium, we're able to connect the cesium up to the firewall in a way to provide a really high level of resiliency, bulletproof, hardening, and tremendously long holdover times. It's got redundant AC, DC power. Of course, it's for critical infrastructure, and we've got some very powerful software monitoring capability, and we're going to show you actually some little demo of that at the end of the presentation. So here's the firewall, and what I wanted to explain to you was this concept of a hardened output versus a validated output. I'm going to start with a validated output. And so as I mentioned, the firewall, just picture this green input line. This is the GPS antenna coming in. And then we've got what we call the validated output going out. So this is what this actually is a pass-through connection. So what's coming in is going out, okay? But what's happening is when it goes into the box, it goes through our detection system. It goes through a set of anomaly detectors that are looking at all sorts of characteristics ranging from the physical characteristics of the GNSS signal, for example, the RF power level, looking at the data of the GNSS or GPS signal itself, all of the different pieces of data that are transferred over that transmission link. And it's looking at also the solution, right? It's looking at the timing quality of the signal. It's looking at the position information, a lot of different characteristics. And if it detects or sees any problems with the live sky signal, what it will do is it will turn off this validated output and allow the downstream system to do what it's designed to do, which is to go into holdover. In this picture, I'm showing our sync server. Okay, that's another one of our products maybe many of you are familiar with. And the sync server contains a rubidium oscillator inside of it. And so when we squelch this validated output, we allow the sync server to go into holdover, and we continue to evaluate the live sky signal. And once we see it look good again, we turn the validated back on and everything's back to normal. The other type of output we have is called the hardened output. And the hardened output is actually a synthesized GPS signal. So inside the BlueSky firewall, we have an actual GPS synthesizer. I'm not going to go as far as calling it a GPS simulator, but it is synthesizing a full-fledged 24 satellite GPS constellation and providing an L1 signal format on this hardened output. And so what happens in the case of the hardened output, when we see a problem on the live sky input, what we can do, either using a MAC, a rubidium oscillator that can be installed inside the box, or an external cesium clock that can be externally connected to the box, we can continue to generate a full-fledged GPS signal even without any live sky signal available at all. And in the case of the Mac, we can develop a hardened output to GPS level quality, I'll call it, for 2 to 3 days. In the case of a cesium hooked up to it, we can maintain that quality for over 30 days. So it allows for an ability to have continued operation even in the complete absence of the live sky signal. So that's a quick overview of the product, of the summary of how we connect it up, how we have this validated output and this hardened output. And, I know there's a lot of information there and some questions, and we'll be referring back to this again in the later presentation. What we recently came out with was support for Galileo. We're seeing more and more customers, even here in the United States. In fact, it's I believe, approved for use in critical infrastructure to not just use GPS, but you can also use Galileo. And so we also have the ability to perform the anomaly detection on the Galileo signal and pass it through, just like we do the GPS. All bands get passed through on the validated, so you could be running Galileo down here. In the case of the hardened output, what's interesting is it's only a GPS format that we synthesize. So what you could do, if you wanted to receive Galileo up here, what we can do is we can map Galileo time onto a GPS formatted output. And this is a really interesting capability for customers who, especially customers in Europe who frankly most of the time are still using GPS, wanting to move towards Galileo, but wanting to take a gradual step. So they want their downstream receivers maybe to still receive a GPS format signal, but actually use Galileo. If anything goes wrong with Galileo, they can quickly switch over to GPS using the firewall without having to disrupt their downstream receivers. So an interesting thing of being able to map Galileo time onto the hardened output the GPS hardened output, that is, of the firewall. A key part, of course, in a firewall, as I mentioned earlier, just like an internet security firewall, and just like with this BlueSky GNSS firewall, is software. We've got certain threats today. We're going to have new ones that come around tomorrow. We're going to have new ones that come around a year or 2 or 3 or more down the road. And so you have to have a system that can be upgraded, similar to any kind of security system, upgraded with new abilities to detect and defend against any kind of anomaly threat. And so we have a software engine inside the firewall that can be securely upgraded. And then we also have something, and we're going to show you a demo of it, a product called Time Pictra that works with the firewall that gives you kind of a bird's eye view where if you have a situation where you maybe have multiple firewalls deployed throughout your network and you want to be able to look, let's say you have a problem pop up in a certain location, you want to quickly be able to see if that same problem is appearing in other locations. You can do that with this product that we have that we call Time Pictra, which has this capability called BlueSky Performance Monitoring. And you'll get a live, or not a live demo, but you'll get a demo of that later on in the presentation. So the BlueSky software, very important. It's kind of the brains, if you will, of the unit, and can be securely upgraded as new threats emerge. Here's some different deployment models. I talked about the validated output. Here I'm showing you again connected to our sync server, which has a holdover oscillator contained in it. So in that case, use of the validated output would be the common scenario. In some cases where we've got equipment that all requires GPS input but does not have a good holdover oscillator in it, they may use the hardened output in that case, or the MAC, depending on how much holdover and how much money they are willing to spend on that particular location. Or a third option is to use it for monitoring only. We have some customers who don't want to put it right in line, but would rather maybe split the signal and have the firewall still do all of that anomaly detection and report up to the Time Pictra system to give them that situational awareness, that visibility of what's going on, but not be directly deployed in line. So lots of different ways that you can deploy the unit. With that, I'm going to dig into this performance monitoring and specifically the subject of monitoring what's called GNSS observables, right? And as we've already talked about, there's lots of different types of anomalies. Some of them occur unintentionally, for example, environmental effects, weather anomalies, multipath interference. And some of them may be an unintentional error that were a human error. For example, a satellite incorrectly getting programmed with information that did actually occur back in 2016. And then, of course, we've got our, unfortunately, our emerging attacks of jamming and spoofing, and even cyber attacks. So a lot of different types of threats out there, and it's important to be able to defend against these type of threats to have visibility, right? Being able to see what's going on and being able to see what's going on very quickly is extremely important in any kind of security strategy. And in the case of GNSS, it's all about being able to look at what we refer to as observables. So what are observables? Well, they're metrics. Okay, they're metrics that characterize the GPS or GNSS signal. And simple ones would be, track satellite counts. Am I tracking the expected number of satellites at a given point in time? Or position dispersion. If I've got my firewall surveyed into a certain position, is the position information that I'm receiving from the live sky signal, does it match? Is it within range? Is it within 1, 2, or 3 meters, or is it not? Is it 20 or 30 or 40 or 100 meters off? Phase time deviation. Inside the firewall, we have our core time-scale technology. Our time-scale algorithms at Microchip, these are algorithms that have been built literally over 20, really probably closer to 30 years from some scientists that are, pretty well known in the timing industry. We have, that's our core competency. So creating an internal time base and then being able to compare the phase time coming from the live sky to our internal time base is a way for us to really detect a lot of different types of anomalies. Carrier to noise, right, is the satellite strength, the signal strength, not signal to noise, but carrier to noise. It's a much more complex computation. Is it within range? Is it within the expected value? Are the satellites in the location that I expect them to be in, right? So not just the count, but are they actually dispersed, appropriately spread out as I would expect them to be? And of course, the things like the RF power is very, very important to monitor. So these are all observables. And, I get asked the question a lot, gee, Greg, this all makes sense. This all sounds good, but how do we know your product works? And the answer, or at least part of the answer to that question, is something that we participate in with the Department of Homeland Security called GET-CI, which stands for GPS Equipment Testing for Critical Infrastructure. That's what that acronym stands for. And this is an opportunity where we come into a live sky environment. So this is not testing done on a lab bench, but in a live sky environment where real live sky jamming and spoofing signals are generated, and our system gets tested against a lot of different scenarios in a real true live sky environment. It's a very unique testing situation, and it gives us the ability to really prove that our algorithms work, and to really show, and in a real environment, that we can provide that kind of protection and security to downstream equipment. This gives you a little bit of a flavor of the kind of testing that we do. So I show, here's a lab testing environment over here. This big blue box over here is a live sky. So literally, we're involved with simulated signals that are generated off of the tower. We rent a vehicle like this. This is our engineers here. We literally set up camp. I can't go into too much detail on this. It is confidential information, but we literally do a lot of different testing in a live sky environment with our product. You'll see, different versions of our products that we've tested, including the firewall right up there on the top. And again, what we're looking for is ways to improve our product, to make it be a better firewall, to make it be more resilient to a threat, to make it be able to recover from a threat better. And so, we're looking at, the waveform analytics, right? This is, looking at the physical attributes of the signal, most notably the RF power level. We're looking at the data, as I mentioned before. There's all different ways of spoofing now, of sending corrupt GPS data, and you need to be able to very carefully be able to detect that. And then, of course, solution analytics, that's referring to the timing characteristics or the position information. And these are some charts that you can actually get directly. We have a couple of different ways. You can get these charts directly from the firewall. And then we also have this BlueSky performance monitoring that I'm going to show you some demos of in the next couple of slides. So here, again, as I mentioned, is the charting capability that we have. We just came out with this charting capability in a new release of software that just came out this month. It's our 2.0 release, and it's also got some interesting new features where we allow the customer to set some of the thresholds for detection. So, for example, when it comes to carrier to noise, if you wanted to set, typically carrier to noise would be set at about 36, 37. But in some cases, customers want to set that lower or higher. We let them set that threshold or the RF power level. So we've added some more programmability into the product. And here I'm showing what you get with time picture. You can actually literally, if you had firewalls, if you were a data center operator and you had firewalls deployed throughout the globe, you could have a global map of firewalls and be able to collect performance information from any one of those firewalls at any given time. So you get a regional or a global view, multi-element view. You can compare metrics from different parts of the world. Really gives you a centralized database where you can store the data over long periods of time, which is very important to do. So here's some example plots, a timing anomaly, a spoof, some phase movement, but rather than spending a lot of time on that, let me show you really what this looks like. Here I'm showing an image from our time picture software. Here is a list of firewalls along the left. So I've got one selected in Rio de Janeiro. Let me go ahead and start running this actually. So you'll see this starting to move down here. Okay, you can see I've got, this is time. I'm looking at phase time deviation, PTD. That stands for phase time deviation. This is in nanoseconds. So this is 0, 50 nanoseconds, 100 nanoseconds. So I've selected phase time deviation, and there you go. There is an anomaly that's occurred. This is an actual live sky anomaly from Galileo of about 200 nanoseconds that we captured, and then it went back to normal. So there's an example of time picture connected to a firewall out in a remote location and connecting or capturing a phase time deviation. So let me click to the next slide. Oops, stop this. So here's an example of what I'm going to show here is a track satellites. Okay, so this is time again along the x-axis, and I'm going to show the number of tracked satellites, and I'm showing 6 satellites being tracked. So let me go ahead and get that started. So this is moving now. And you'll see all of a sudden we're tracking 6 satellites, and then all of a sudden we see some movement down to 1, but then all of a sudden a much larger drop down to 3, down to 2, down to 0, and over a very short period of time. So that is a classic example of a spoofing event, all right, where someone captured the receiver and knocked off the satellites. A typical term, a common term you'll hear is something called a knockoff signal. And that's where the spoofer will generate a signal at an RF, they'll put it right at the center frequency and kind of knock off the receiver and then generate their spoof signal at a power level that's just a little bit higher than the live sky signal. So the receiver gets captured. So, one of the key things we have that's really cool in our system is RF power protection. I'm not sure that I have a demo of that, but it's a very important capability to be able to detect quick and sudden power disruptions. A lot of times I see interesting talks, and I don't want to, discredit, some of these, different types of tools like anti-jam antennas, for example. They're very effective in protecting against jamming, but, when you have quick knockoff events, really you need to have a much more sophisticated detection system like you're seeing here. So let's go to another example here. Here is one where I'm going to show another phase time deviation. This is another phase time deviation example, but this is a classic example of even though you're seeing change in time, you're seeing a fluctuation in change in time. I'm still showing nanoseconds here, up to 150 nanoseconds, but this would be an example, and we can't go into details on this, we're going to not have enough time, but this would be someone playing with the pseudo range of the satellites, and you would see something like this show up in the phase time deviation. So this is actually a simulated anomaly that we wanted to show you, but it's a simulation of a pseudo-range type of anomaly captured using phase time deviation. So let me click the one more. Here's a position. I'm going to show a position delta excursion of GPS. Let's see what this one looks like. I've got the threshold set to 30 meters. So I'm, under 10 meters, which is normal. But then all of a sudden up I go and cross over 30 meters, back down, and up I go again. So this is someone who has, again, maybe done a knockoff signal, captured the receiver, generating a fluctuation in position information. This can cause havoc and real concern, obviously, in terms of, whether the signal is valid or not. So those are some examples, again, of this product that I mentioned called Time Pictra. It's a software product that works with the BlueSky Firewall. We sell it along with the BlueSky GNSS Firewall, and it's a very powerful tool for being able to monitor these GNSS observables, being able to track what's going on in different locations, and really have a bird's eye view, kind of 24/7 with all the data captured in the database. And it's a great way to be able to show not only when a spoof or jamming event occurs, but I think equally as important to show that things are working well. I think in my experience with talking to customers too many times have this perspective of, this all looks really cool and really great, but I'm just not experiencing any jamming or spoofing. And that may be true. They may not be getting affected by any jamming or spoofing, but that does not mean that there's no jamming or spoofing happening around them. And if it is happening around them, it's something to be aware of. It's something that you want to know about. And being able to record and store this type of information using Time Pictra with BlueSky Performance Monitoring is the way to answer that question. So, clicking ahead. Here is a picture of an actual deployment. This is it's a stylized picture, admittedly, but this is a deployment of an aviation application. This is in the aviation industry. I'm going to just go ahead and mention this is in, I'll say a Scandinavian region. This is a solution that was deployed at every airport in the country. Okay, every airport in the country, they deployed a BlueSky firewall. They deployed it along with another product of ours called the Time Provider 4100. That's this product that you see right here, and right here, and right here. They also deployed it with some time cesiums. And what they had was a collection of airports, about 72 airports, that were connected on a private SONET, or in this case, an SDH network. And they're migrating this network to a packet network. So they were interested in our Time Provider 4100. They were interested in having that network secured. So that's why they wanted the BlueSky GNSS Firewall. They wanted at some of the locations, for those locations to be what's called, think of them as a timing hub location. So they had some cesiums deployed there. And when they discovered what the firewall could do with Time Pictra, what they said, wait a minute, we don't want to deploy this just with the Time Provider 4100, which was actually only at about 20 locations. We want to deploy firewalls everywhere, because not only do we want to use the firewalls to secure the actual physical transport network, we want to use the firewalls as a situational awareness detection system to make sure that the GNSS reception on the grounds of the airport is not seeing any kind of jamming or spoofing or disruptions of any kind. Because if we do see anything, we want to be able to tell the pilot, don't use GPS for this landing, because we're seeing something odd going on around here. So the point I wanted to make here was that we went in there to sell them a solution for a secure networking problem that included our Time Provider 4100 and the firewall and the cesiums, but they ended up wanting to use it not only for that, but also for situational awareness on just generally, is there any jamming or spoofing occurring on the airport premise? So I think this is a classic case of the value, again, of time, picture, and performance monitoring and what we can bring to the table with a complete solution. So I'm going to wrap it up here, and I want to leave some time for some questions. You know, sometimes our information can be a little hard to find because we were Microsemi, but then we were purchased by Microchip. In fact, I think Ryan even, you know, described my background a little bit. You know, I go way back to the Symmetricom days. It gives you an idea of how old I am. But you know, we do have our product information now on a landing page on Microchip. But when you click on the individual stuff, it will take you over into the Microsemi website still, where you can find more detailed information. And on the Microsemi website, I really encourage you to look at the BlueSky GNSS Firewall page and look at some of the stuff we have there under webinar and videos. We've got some cool videos of the product. This one actually does a full demonstration of capture of a live, not a live sky, but a simulated signal. And we've got some other interesting videos and some really good white papers and data sheets that can dig into a lot of this information I'm providing you in more detail. And with that, I want to, you know, first thank you for listening to me. You know, I know everyone's very busy these days, and I hope you guys are all healthy and being safe out there, and we appreciate you being able to join us virtually. Although I am located out of our Boulder office here in Colorado. I personally live in Broomfield. I'm at the home office today. We have been able to go in and out of the office because we are a government facility, and so I have you know, government, you know, clearance to do that and to go into the office. But I am working remote today, as I'm sure many of you are. And again, I just like to thank you for your time, and you know, look forward to talking with you more about the product and with our using it through our partner Vic Myers. And with that, we'll leave it to some questions. I'll turn it back over to you, Ryan.
Very good. Thank you so much, Greg. That was jam-packed with a ton of value and some good resources at the end. I've got a couple of questions from the audience to kick this off. We've got about 10 minutes for questions. We'll get to as many of them as possible, and then we have all the questions and comments as well. So if there's anything we need to follow up on after the top of the hour, we'll do so directly thereafter. The first question that came in from the audience says, how much delay from the GPS input to the hardened output, Greg?
Excellent question. Wow. Okay. That was a really good question. And the answer is 0. In the case of the hardened output, what we do at the factory is calibrate out all of the delay. So, okay, 0, that's a pretty brash statement. But it's pretty close to 0. Okay. You'd have a really hard time, you know, making that phase measurement difference between the input and the output of the hardened output. Now, if I could add in to that question, in the case of the validated output, because we're passing through the signal, you can think of it almost as a wire going through the system, there is some delay, okay? And we can't compensate that out we don't compensate that out at the factory. There's also cable delay naturally. But, you know, you can compensate that out. We do have a cable delay setting, so you can cancel out that delay that goes through the validated output, which is typically around 2 to 3 nanoseconds. But in the case of the hardened, it's, you know, pretty close to 0. Great question.
Very good. Another question here. Does this work with CRPA type antennas?
Yes, it does. It works with any antenna.
Okay.
So it's works with the circular CRPA antenna or any standard antenna. And again, it's a real simple installation, as I described. It's really just a matter of disconnecting your cable from your current receiver and putting it into the input of the firewall, and then depending on your application, hooking up the validated or the hardened to your downstream receiver. In fact, it's very complementary, I would say, with the circuit antenna.
Okay. Thank you very much. Another one here. Does the tool query what the expected number of birds versus the number of actual birds via OTA?
Versus OTA, meaning like over the air, maybe a little more clarification on that. I mean, the short answer is, do we query? Well, can you get a little more clarification on that?
Yeah,
like,
you can clarify over the air. Does the tool query what the expected number of birds versus the actual birds over the air? So if there's any more clarity on that.
Yeah, currently, no. The short answer to that is currently, I mean, we're tracking satellites and, we're tracking what we expect to see. And if we see something out of range, we raise an alarm. What we do have, and we just introduced in our current release of software, is we have a setting. We have that threshold configured. It's currently configured for a minimum of 4 satellites. But you could set the setting higher, for example, if you wanted, if you know that your particular antenna location should have no problem consistently seeing a minimum of 6, as an example, you could set that threshold setting to 6.
Okay. So it does not query national databases over the internet?
No, we no. But we are, it's a great question. We don't currently do that, but we are looking at doing that either directly from the box or through our time picture system.
Okay. A question here about SASM. For customers using SASM M-code receivers, does BlueSky provide measurable inputs in security?
Excellent question again. We think the answer to that is yes. We have customers who are using BlueSky with a downstream SASM receiver. And so, the first point I'd like to make is it passes, in this case, they'd be using the validated output. So, imagine antenna input to the firewall, output from the validated output to the downstream SASM receiver. And, the SASM signal will get to that downstream receiver. And again, we think the firewall, using, for example, the BlueSky performance monitoring, provides some great additional information on GNSS observables. It's very complementary. And, does it add more security? I'm not going to go as far as to say that, but it certainly adds another level, if not more, visibility.
Okay. Question that just came in. Are all measurements done at the message output of the receiver, or is there some ADC subsystem in line to perform measurements?
We don't have a ADC system in line per se. We do have a pretty sophisticated RF front end to the system. So all of our RF analysis is done outside. It's done with a separate standalone circuit. So being able to, for example, do knockoff detection is something that we do separately in a standalone circuit. But we don't have a separate analog to digital converter, if you will, on the front end.
Okay. Do you have any pictures that show the difference or showing the delay from the GPS to the hardened output in reference to the question earlier where you stated that it was 0 or close to 0?
We could pull calibration reports probably, I think, for that.
Okay.
So maybe that's something we would follow up with the Vic Myers team separately.
Yeah, no worries. We've got the contact information here, and we can do that. A question here says, "This subject is new to me. How do I get started?"
I think the important answer to that question, I'm not trying to be clever, but is to get started. And in a lot of cases, customers, they may not be experiencing spoofing and jamming. And and that's okay, and we get it. But to do nothing is really not a good approach, given the amount of news, and now even more importantly, the executive order which has been issued. So, for example, maybe starting with just 1, 2, or 3 units, deploying them in different locations. They can even be moved around over time, and at least starting with some level of monitoring. If you don't want to hook it up in line and disrupt your current infrastructure, hook it up to the side for monitoring purposes, and start to do some surveillance and start to see what's happening and look at these different observables. We think that certainly is a good first step to get started.
Okay, another question that just came in. Other than the time picture web interface, is there some other instrument communication set with I/O messages?
Absolutely, there is. The system comes with several different ports where you can communicate it. We have a standard, CLI kind of interface where you would send a command and receive a response, kind of a, ask for status and get a status tree back of a lot of different information, or even down to a more specific, metric that you might want to look at. So we have a whole complete command set. We also have ports that you can turn on and that just kind of, spew out, if you will, the data in a format that's more machine to machine readable. Okay. So that's another way. So we have a few different ways down at a few different ports that you can work with. And I wanted to mention, in addition to the time picture, we also have a GUI interface directly from the box. So even the charting that I showed you examples of, that same, a similar looking, well, I'll just say the same observables, we have charts that come right off of the box as well that you can access securely using a web browser.
Okay, I think that answers that very well. And again, I have all of your contact information. So for a couple of those follow-ups, we'll make sure to reach out to you directly. I don't see any more questions coming in, so I think this is a good time to wrap it up, Greg. Again, thanks for your time. Thanks to everybody who was able to take the time to join us. We certainly look forward to being out and about in the fields at some point in the future. But until then, please use our website, use the Microsemi website, reach out to your local representative. We'll make sure all of our contact information is sent to the attendee list, and will be located also on our website so that you can send those links out to your coworkers. From everybody at Microsemi and Vic Myers Associates, we really appreciate your time, and we hope you stay safe out there.